Okay, today I'm going to be going over Module 19.1, Understanding Quadratic Functions. The essential question is, what is the effect of a constant a on the graph of f of x equals a times x squared? And we're going to be talking about what the parent function of a quadratic function is. So let's scroll down. It says, understanding the parent function of a quadratic function. So a function can be represented in the form f of x equals ax squared plus bx plus c, and this is called a quadratic function. Okay, what makes it the quadratic function is that the exponent, the greatest exponent, has a variable of 2. Okay, a, b, and c in this equation here are just numbers. They're just constant numbers. So a could be 2, b could be 3, c could be 4. It doesn't matter. They're just numbers. The most basic quadratic function is the parent function f of x equals x squared. And so we're going to look at that function here, and it says, here's an incomplete table of values for the parent quadratic function, complete it. So if you plug in -3 squared is 9. If you plug in -1 squared is 1. If you plug in 0 squared is 0. 1 squared is 1. 2 squared is 4, and 3 squared is 9. So what number goes here? So what number squared gave me 4? Well, 2 and -2. So if I were to plot these ordered pairs, I would have -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Now, if I connect them, it's going to be a curve. The highest exponent is greater than 1, so we're always talking about a curve when we have that. So if I curve this, I should get a U-shaped graph. Okay, the curve is called a parabola. The point through which the parabola turns direction is called the vertex. So this right here is my vertex. In this one, the vertex is 0, 0. A vertical line passes through the vertex and divides the parabola into symmetrical halves. Those two symmetrical halves are called the axis of symmetry. So right here is my axis of symmetry. And that axis of symmetry is cutting this U perfectly in half. So if I drew this perfect U shape here, you should see that these two are symmetrical points, these are symmetrical points, and these are symmetrical points. We're going to go ahead and go on to the next part. So we are on page 889. We're turning the page to 890, and we're going to go over the explain 1. So explain 1 is talking about that a, if you multiply a to the x squared. So the graph of g of x equals a x squared is a vertical stretch or compression of a parent function. The graph opens upward when a is greater than 0. So in this case we have a vertical a vertical stretch when a is greater than 1. So numbers that are greater than 1, let's say it's 2. So if this was 2, it would be a vertical stretch. If it was 3, it'd be a vertical stretch. If it was 4, it'd be a vertical stretch. A vertical compression, however, is when a is between 0 and 1. So numbers that are between 0 and 1 are fractions or decimals that are less than 1. So we could say if a was 1/2, or if a was 1/3, or if a was 2/5, right? Those are all numbers less than 1. And this is what it would do to the graph. So the parent function, I'm going to highlight it in yellow. This parent function, the standard one that we just drew, is the one that we are seeing how it changes. So a vertical stretch is this one here where it stretches it and it makes it skinnier, if you will. A lot of textbooks used to call it narrower, hence narrower right there. And then for the compression, it's like you're squishing it down. So it actually makes it fatter or wider. So when you multiply by a fraction, it makes it wider. I'm sorry, a fraction less than 1, right? Because it's squishing it down. And when it's a is greater than 1, it's making it narrower. So let's look at example 1 and see what this does. So in this example here, they already filled in the t-chart for us. They plugged in -3 and they said -3 squared is 9 and 9 times 2 is 18. -2 squared is 4, 4 times 2 is 8. So they filled this in and they went ahead and graphed it for us. And what it wants us to do is graph the quadratic function by plotting the points, which they did for us, and then state the domain. So all they did was they took those points and they plotted it. Now, -3, 18 is way off the graph. So then they went to -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. And then they graphed it. One thing that it doesn't ask us to do is to find that axis of symmetry, but I want us to get in the habit of drawing this. This is the axis of symmetry. This is the line that would cut this parabola perfectly in half. And then it does say state the domain and the range. So for my domain, it's all real numbers. Now, why is it all real numbers? It's going on for infinity out this way, and so x can be any number. Same thing here, it's going out for infinity, so x can be any number. Domain is looking at your x values. Your range is your y values. So if I'm looking at my y-axis, are there any values that are down here? No, it actually starts at 0 and they all go up. So that's why we have y is greater than or equal to 0. Now going on to example 2 on the next page, 891. Example 1, part B. Let's do that for this one here. So if I plug in, there we go. If I plug in -3, I'd have -3 squared is 9. So 1/2 times 9 is, we can either do this in decimals or we can leave this in fractions. So we'll say 9/2, which is 4.5. And -2 squared is 4, so 1/2 times 4 is 2. Plugging in 0, I get 1/2 times 0, because 0 squared is 0, and I get 0. 2 squared is 4. Half of 4 is 2. And 3 squared is 9, so I get 1/2 times 9, again, is either 9/2 or 4.5. So let's go ahead and graph this. I have -3, 4.5. I have -2, 2. I have 0, 0, 2, 2, and 3, 4.5. So notice when I graphed this, I just made a t-chart, right? So step 1, make your t-chart. Step 2, plot your points. And then I'm going to add step 3, which is your axis of symmetry. So your axis of symmetry, remember, is that line that's going to cut it in half. That line right there is the line x equals 0. Right, because x equals 0 here, 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 here. So that line is called x equals 0. And then it wants us to find our domain. So again, look, these x can be -1, -2, -3, and -4, and it's continuing on. So it can be any value from -infinity to +infinity. And my range, again, is starting at 0 and going up. So y is greater than or equal to 0. One more thing we should get in the habit of doing is labeling your vertex. So my vertex is here, and my vertex is the point 0, 0. So I'm going to write that here. Okay, so you have your turn 4 and 5. And explain to Explain 2, I'm actually going to go over very, very briefly. I just kind of want to use some common sense here. It says the graph of y equals negative x squared opens downward. Well, now think about it. No matter what values you plug in here, you're going to multiply by a negative. So it's going to take all these positive numbers that we had in our parent function, and it's going to multiply them by a negative. Well, if you multiply, let's see, this was the point negative 2, 4. If you multiply 4 by a negative, you're going to get negative 4. If you multiply, this was the point 1, 1, or negative 1, 1, and you multiply 1 by a negative, you're going to get a negative 1. So it just means that when you multiply by a negative, your u is now going to go downward. And the book separates it as vertical stretch or vertical compression, but look what happens with both of these. You flip it downward because of that negative, and then with the compression it just makes it wider, or like with this one it made it narrower. So let me show you what that looks like quickly. So in this one, if we took a negative and we multiplied there, it would take all these values and make them negative. So again, we just plot those points, sketch it. I like to label my axis of symmetry. I try to make it a dotted line so it doesn't interfere with my graph, but that's a terrible dotted line, sorry. And that's x equals 0. Your domain and range, again, all real numbers or negative infinity to infinity. And your range is, now here's where something changed. Because it's now going down, it's the biggest number y can be a 0, and then it has to be less than that. So y is less than or equal to 0. For this one here, if you recall the values we just had in that other one, we had 4.5, 2 squared was 4, divided by 2 is 2, 1, this is a 1/2, 0, 1/2, 2, and 4.5. So these were the values we had in the other t-chart when we didn't have that negative. Well, what's that negative going to do? It multiplies all of these by a negative. So if I graph these, and if you don't believe me, plug it in yourself. But if I graph these, -3, -4.5 here, -2, -2, -1, -1/2, 0, 0, 1, -1/2. And if you recall, everything's symmetrical, so you can kind of eyeball it as long as you did your t-chart correctly, right? So now if I sketch this, make that a U, your domain is, let's see, x values can be all real numbers, so all real numbers. And your range has to be, y has to be less than or equal to 0, because it starts at 0 and it goes down. I like to label my axis of symmetry, and that's that dotted line down the middle of the parabola. That dotted line is at x equals 0. And my vertex is this point here, 0, 0. So as far as graphing these, remember, it's just 1, t-chart, 2, plot, 3, do your axis of symmetry, and 4, label your vertex. Okay, whether it's a negative in front or not, remember negative just means it's turned downward. Positive coefficient means it's going upward. Good luck.